Last episode, we built an AI agent that reads a failing CI/CD pipeline and writes the fix, but it still needed a human to apply it. Today, we remove that last step. By the end of this video, the agent will open the pull request itself, branch, commit, and description, all hands-free. Quick recap if you missed part 1. A build fails. Our agent reads the log, diagnoses the root cause, and returns a structured fix, a category, a confidence score, and a Git-applicable patch. Structured outputs made it reliable. A strong system prompt made it safe. If you haven't seen it, the link is in the description. But here's the gap. A patch printed to a terminal is still homework. Someone has to copy it, create a branch, commit, push, and open a pull request. That's 5 manual steps between the diagnosis and the fix. The last mile is still on you. Today, we automate the last mile. Here's the plan. First, a quick look at how agents use tools. Then we connect the GitHub MCP server, the connector that gives our agent real capabilities. We upgrade the agent from one call to a tool using workflow. And then we watch it open a real pull request, with guardrails that keep it safe. First concept. Tool use. On its own, a language model can only produce text. Tools change that. We hand the model a list of functions it's allowed to call, with names, descriptions, and typed parameters. When the model wants something done, it doesn't do it. It asks. It returns a structured request. Call this tool with these arguments. The tool runs and the result goes back to the model. That request and response cycle is the agent loop. The model reasons, picks a tool, the tool executes, and the model observes the result. Then it decides the next step. Reason, act, observe. Around and around until the goal is done. The model is the brain. The tools, and your permissions, are the hands. Now, where do the tools come from? You could handwrite every GitHub API call yourself. Or you use MCP, the Model Context Protocol. An MCP server is a ready-made connector that exposes a service's capabilities as standard tools any agent can call. Plug it in, and your agent instantly knows how to talk to GitHub. The GitHub MCP server gives our agent exactly the tools it needs: create a branch, push files, and open a pull request. Each one is typed and described, so the model knows when and how to call it. And the crucial part, the server holds the GitHub token. The model never sees your credentials. It asks, the connector acts. So here's the new architecture, end-to-end. A failing build triggers the agent. It diagnoses the root cause. That's episode 1. Then, through the GitHub connector, it creates a fix branch, commits the patch, and opens a pull request, with its explanation as the PR description. A human reviews and merges. The loop is closed. Let's write it. First, we declare the MCP connection, the GitHub server, and the tools our agent may use. Notice the allowlist: create branch, push files, create pull request. Nothing else. No merge. No delete. No admin. An agent should get the minimum set of capabilities the job needs. Next, we extend the system prompt with the new rules of engagement. Open a pull request. Never push to main. 1 fix per PR on a fresh branch. Explain the root cause in the PR description. And if confidence is low, don't open a PR at all, just report. The prompt is where policy lives. And here's the run itself. We pass the connector and the allowlist straight into the API call. The platform manages the agent loop for us. The model picks a tool, the call goes through the connector, the result comes back, and it keeps going until the job is done. 1 request from our side. A whole agentic workflow on the other. Finally, we wire it together. Diagnose the failure. Same as episode 1. If confidence is high and the category is low risk, run the PR workflow. Otherwise, post the diagnosis to a human. The auto-apply gate from last time just became the auto-PR gate. Time to run it. Same broken build. The Flask and Verksug version conflict. Watch the tool calls stream by. Create branch. Fix Verksug pin. Push files. Requirements.txt. Create pull request. And there it is. A real PR with the diff and the agent's diagnosis written as the description. From red build to reviewable fix with no human in the middle. And look at what the reviewer sees. The root cause up top, the confidence and the category. The exact one-line change. This is the point. The agent doesn't just fix things, it shows its work. Review takes 30 seconds instead of 30 minutes. Now the serious part, safety. 4 rules. 1. The token is fine-grained. This one repo, contents, and pull requests, nothing more. 2. The agent can propose, never merge, and branch protection enforces that at the platform level, not just in the prompt. 3. Every action is logged. The PR is the audit trail. 4. Low confidence means no PR. Defense in depth. Prompt, permissions, and platform. Quick cost check. This runs only when a build fails. A typical run is 1 diagnosis call plus 3 or 4 tool calls, a few cents. Compare that to 15 minutes of engineer time on every failure every day. This is the cheapest teammate you will ever hire. So that's the upgrade. Tool use lets the model act instead of just talk. MCP connectors give it real capabilities with no custom glue. An allow list and a hardened prompt keep it on rails. And the pull request keeps a human on the merge button. Next episode, we point this agent at production alerts. AI on call that triages your pager before you even wake up. The full code is in the description. Subscribe to AI Ops Academy, and I'll see you in the next build.